Okay, for today's classwork, I would like you to copy onto the pages I've given you every problem I'm showing you here. So the first one here, when I'm asking you for transformations, you can see the ghostwriter always starts with doing a reflection. So a reflection is going to be equal distance over an axis line here, either the x-axis or the y-axis. First thing I'm doing is just trying something over the x-axis here, this vertical line. So 3 above, 3 below. I can see if I do that, in another step it's going to be impossible to almost get it over there. So that's not the one I want to do. So again, I'm going to go back and now reflect over the y-axis, this up and down line. And once I do that, I can see I get almost the same image, so that's the combination I'm going to use. I'm going to first reflect over this y-axis, the vertical line, a flip, equal distance, this point 3 across, 3 left, 3 right, 3 left, and then I could see from there I'm going to be sliding this up, left 2, up 3. I could see that motion, left 2, up 3, minus 2, up 3. That should be a minus right there. Left 2, up 3. So my slide, taking that, left 2, up 3, this little arrow describes that motion that I'm sliding left 2 and up 3. That's called a vector. Another way of showing a translation or a slide, the direction you're moving. So I'm moving that left 2, up 3, left 2, up 3. I can see every point moving left 2, up 3, left 2, up 3. So those are my two transformations. I'm going to write that as not a flip, even though that's the low-tech way. I'm going to write it as a reflection. Don't write flip. And then, of course, the low-tech way, a slide. We're going to call that a translate. Make sure you use the right language there. So for my writing, I'm going to write the first transformation. And sorry about this little glitch right here. First transformation is reflect across the y-axis, or reflect over the y-axis. Notice I'm writing reflect and I'm writing the line that I'm reflecting over. Second, I'm doing a translate, a slide. Don't write slide, translate. Use the right words. Translate, left 2, up 3. If I want to write that a different way, I could write that as x, the left or right component, x minus 2 because I'm going left 2, y plus 3 because I'm going up 3, y plus 3, a different way of showing left 2, up 3. Alright, this one, again, do a reflection, see what you get. This one has 3 transformations I could tell. This is the original, I could tell, no marks. This one, I could see after 3 separate movements got to here. That's what those marks mean. So again, on these, always start with a reflection. Reflect over y, reflect over x, see what you get. So I'm going to take this and reflect over the y-axis. So going straight across, equal distance, I could see 2 across, 2 across. Probably not going to work for me. Let's replay that again, if I could. I'm going to instead reflect this one over the x-axis. And again, I did that pretty quick. But if you reflect over the y-axis, not quite going to get you that look that you're looking for. So yeah, it would probably be tough right there to get this triangle to look like that. So I'm going to reflect over the x-axis instead and see what I get. Alright, and then what I'm going to do is reflect this over this y-axis. Kind of looking like maybe it might be a better combination. So over the x-axis first, and then I'm going to reflect over the y-axis second, and then I could see now I'm just sliding this up, left 1, up 4, left 1, up 4. I could see that. Left 1, up 4, left 1, up 4. This little arrow written up here in the space somewhere, again, I could draw a vector arrow anywhere I want as long as it's showing left 1, up 4 motion. I could write that vector arrow anywhere I want. That describes that motion, left 1, up 4. So my last transformation is a translation, left 1, up 4, left 1, up 4. So to write these out, number 1, reflect across the x-axis, or reflect over the x-axis. Don't just say reflect. Reflect over the x-axis. Don't say flip. Say reflect. 2, reflect over the y-axis. Equal distance on either side of that y-axis major line. And then number 3, I did a translate. And I did left 1, up 4. Left 1, up 4. I could write that as x minus 1, describing that left to right motion, minus because I'm going left, plus 4 because I'm going up. Alright, the next two, I'm going to give you what I'd like you to do. So for this one, I want you to first translate x plus 3, y minus 2. So I'm going right 3, down 2, right 3, down 2. And then I'd like you to reflect over the y-axis, which is the up and down axis line, not the side-to-side vertical x line. Make sure you know the difference. So translate. I'm going right 3, down 2 for every point on this triangle. Focus on the 3 endpoints, the 3 vertices. Take that point, right 3, down 2, right 3, down 2. That's going to be the new C right there. I can describe that motion again with an arrow going right 3, down 2. That describes that motion, that translate. That's called a vector. Right 3, down 2. So when I write that the right way here, if I could fix that, gives me this triangle, right 3, down 2. Check. Every point, right 3, down 2, right 3, down 2. Vector arrows connecting all those points. Now I'm going to reflect not over this x-axis, over this y-axis line, this up and down line. So now I need to count boxes. 1, 2, 3, 4. Equal distance. If this is 7 boxes, 1, 2, 3, 4, 5, 6, 7. Other one, 7 to the other side of that line. This point, 7 to the right. The reflected point, 7 to the other side of the line. This one way over here, 11 on the right side of the reflected line. The reflected point, equal distance, way over here, 11. That is the reflected triangle. To get to spot 2, make sure you label. This is ABC, the pre-image before the move. This is B prime, A prime, C prime after one move. And then after my second move, I could see this is B2, or I could write that B double prime. This is A2, and this is C2. Make sure you have the right label so I know first one to here, second one to here. I could see that. All right, last problem. A little bit more complicated. I'd like you to reflect over the x-axis, this line right here, the x-axis line. And then number 2, reflect over the y-axis, which is this line right here. And then number 3, I want you to then reflect, and I'm going to give you a brand new line over the line. And the line I'm going to give you is going to be, I'm not sure what I gave you. I gave you a y equals 3, which is a horizontal line through 3 on the y-axis. That's what that line is. Know how to graph those. Y equals 3. Straight horizontal line through the 3 on the y-axis. All right, first thing, reflect this triangle over the x-axis. So I'm going equal distance over this x-axis line. One above, one below. And again, you'll always get that reflected shape. You can see that this isn't just moved down here. This would be folded on top. That's that look, the reflected look. So B1, A1, C1. Next, I'm going to reflect over this y-axis. So this up and down line. So now I'm not going up and down. Now I'm going left or right. Right 4. The other one's going to be left 4. Right 4, left 4. And then this one, right 8, left 8. Not up there. Nope. Way over here. You could see that would have not been the reflected look. That's the reflected look. And now what I'm doing, I need you to know that the line y equals 3, I'm going to plot it for you, is the line right through here on the y-axis, y equals 3. Every point on that line is 3 for y. That's how we get the line y equals 3 right there. And I'm going to have you reflect this red triangle over that line, not the x-axis line, not the y-axis line, this new line. So this B point, 4 below, 4 above this new line I'm using. So again, I could shift my reflection lines. And then this one is going to be 6 below, 6 above. This one, 6 below, 6 above. And I could see I get that reflected look not over the x-axis line, but over this line. If I was to fold this paper along this line, this would fold right on top. And then my labels, I can see that this is A1, B1, C1, second one, third one, label it. Good luck.